Hi everyone, I'm really happy to have you today for this very first Picterra webinar, actually. We'll see together how to scale up your aerial mapping business using AI-powered object detection. A few words about Picterra first. We are a Swiss company created in 2016 and based in Lausanne at the Innovation Park of BFL, nearby the shores of the Geneva Lake. We are reaching users globally, and we are very happy to have people today joining us from the 5 continents. So I'm Franck de Morzier, one of the 2 co-founders and CTO at Picterra. And I'm here today in this webinar with Roger.
Hello, I'm Roger, and I'm the computer vision engineer at Picterra.
I will first provide a quick overview of our product before Roger will walk you through the platform and really do a live demonstration of the custom detector workflow. He will highlight the key actions and understanding to get the best out of it. We invite you to ask questions in the chat. Julien will collect the questions and answer to some of them at the end of this webinar. We'll also send an email next week with the answers to the questions that could not fit in this short time of the webinar. So let's go for an overview of our solution. We are providing a customizable and scalable solution in the form of a web platform to extract geospatial information from aerial and satellite imagery. You can easily detect, localize, and count objects. You can identify trends or classify patterns of an area. It's definitely to boost your capacities in analyzing at scale your imagery. And the idea is that it broadens the type of geospatial insights you can directly deliver from your data. Our platform takes place between the Earth observation data and you, and the data really can come from any drone. Ideally, your data is georeferenced orthomosaics, but you can also work with individual images, surface models, or vegetation indices directly. There's no need to be a machine learning expert or data science expert. We are taking care of the machine learning models, their deployment, the required IT infrastructure, and we keep all of this up to date. The idea is that we made it transparent for you, so the technology should disappear and really allow you to concentrate on your expertise and the job you're trying to do. One thing to mention, Picterra is not only a tool, it's also a community of users. You are benefiting from this community to build much quicker and accurate AI model, and you contribute back to the community by indirectly improving the general performances of the detectors. The data privacy is respected. The learning approach enables the pools from each other without privacy breach and without directly sharing the data. In the end, the only thing you need is a web browser. From there, you can start to detect in a few clicks. You get statistics also at a glance. You can share your results or generate reports, and directly from there, share it further with your colleagues or customers. In terms of data, you can bring your own imagery, but we can also organize the acquisition of up-to-date imagery from a set of resellers and partners. We can also provide a global coverage layer, as you find on Google Map, Bing, or Mapbox. Regarding the detection capacities of the platform, you can map things like urban elements, such as roads or buildings. You can localize features, like solar panels, for instance, and you could estimate then the remaining roof surface available for new panels that you would place. You can count vehicles or distinguish different types. You can localize crops or trees. You can spot the dead ones, for instance, or estimate canopy openings in a forest. You can count and localize a variety of animals, from cattle to birds, not forgetting bisons, turtles, horseshoe crabs. There's no real limit in what you can detect, actually. As we used to say, if you can see it, AI can learn to find it then. I'll now let Roger to take over and show you really how to use the platform in a real demonstration.
Cool. Thanks, Frank, for the intro. And now I will get into the heart of the platform itself, which is the custom detector. So before I do the actual demo of it, let's motivate the custom detector a little bit. So one question you might have is, are there other companies in the geospatial domain that are also working with machine learning and AI? Well, the answer is yes, and the solution tends to come in two different forms. It's either a consulting company who develops from scratch a custom solution for you, which may take up to months, if not more. Another option is built-in detectors. And so built-in detectors, as we like to call them, basically these are AI models that are trained on very large data sets for one very specific purpose. For example, on the Picterra platform from back in the day, we have a few of these built-in detectors. One of them is a vehicle detector. However, imagine you were trying to detect trucks all of a sudden and not all the other vehicles. Well, in that case, you would be out of luck with these built-ins because the built-in has only been trained to do one thing and one thing alone. So the key thing here is that these built-in detectors lack flexibility, customizability. So what we realized here at Picterra was that the one who can best train an AI model for your task is not some consulting company, but it's you, yourself. You are the expert of your domain, your geography, the aerial platform or drones you've taken your images from, even maybe the season or illumination that you're working with. So therefore, you know how to create the best AI model for your needs. So how do we train a custom detector? This might sound a bit like magic, but I'd like to make an analogy with training a newborn baby. So the AI starts off knowing nothing about the world. So you have to tell it a few things. You have to tell it what it should do. You have to tell it what it should not do. You let it try some things out, try to detect some objects, etc. It's going to make a few mistakes at first, but then you can go back and correct its mistakes. And then after a few of these iterations, your AI baby will have grown up to be a professional detector of whatever you want it to be. A key point to stress here is that it's really about the quality of the data, not the quantity of the data that you feed your detector. With these built-in detectors, you're oftentimes feeding in massive amounts of data, but a lot of that is actually quite unnecessary. What we find is that you don't need like tens of thousands of annotations. Maybe tens or hundreds at most is sufficient for most use cases. So let's go through the workflow steps. There are two major concepts you have to understand. These are training areas and annotations. So let's start with training areas. So most of you might be coming in with some kind of a large raster. So in this case, on the left-hand side here, we see a farm filled with sheep, and the goal is going to be to detect the sheep. And so on the left side image, as you see, we've drawn a number of boxes. So what these boxes are exactly training areas. If you look on the right-hand side, we have an image that shows you exactly what your AI baby model will see when you're training it. So now the next logical question is, well, how do I choose these training areas? How do I find the best training areas to feed my AI baby? Well, it might seem a little bit intimidating at first, but I think you'll find that it's actually quite intuitive. So here's an example of the first few training areas that you might make for this particular image. So on the left here, we have training areas, a training area that is over our object of interest, the sheep. So in addition to this, we'll also have to annotate the sheep in a later step, but you'll see that in a second. Basically involves drawing outlines over the sheep so that the model knows where in your training area are the sheep exactly. The other two are a bit less obvious, but very important. So if you look at the top right training area, this training area is only over grass, and you will annotate nothing in this training area. The reason for this is that you want to teach your model to not try to detect the grass. So what about the bottom right training area? Well, if you were using only the top two training areas that I just mentioned, what might happen is that your model thinks that you're just trying to detect animals or whitish animals over a green grass background. However, in this case, we're trying to detect the sheep. And these dogs might be accidentally mistaken for these sheep. So what do? Well, we simply draw a training area over these dogs, and we will be sure not to annotate anything inside this particular training area so that we teach the model, this is what you're not looking for. So let's get to this annotation step. This is a summary of the different types of training areas you can create. So for the annotations, basically it's very straightforward. All you have to do is annotate all objects of interest inside your training areas. So here we've outlined the sheep. And in the other two training areas, as I said before, we're going to outline nothing. And these outlining tools are all in the platform itself, as you will see. One technical note is that if your application is to count the sheep, it's better to actually leave the annotations slightly separated so that when the model outputs the results, it'll output separated results, which will make the count more accurate. So after you've done this, the next step is as simple as just clicking a train button. So the train button takes your data set of training areas and annotations. It trains the model using Picterra's AI. You have to know, all you have to do is wait for a short while, approximately 2 minutes, and then you preview the results. Now, once you see the results, it might make mistakes. So you'll look over it. You'll find the areas where it's having difficulty, where it might have false detections, or it might make mistakes. And then you will draw more training areas and more annotations on top of those areas and improve your detector over time. At the end of the day, you might get output that looks something along the lines of this. But we'll see this in a second in a live demonstration on the platform. So let's just switch to that real quick. So here is the Picterra platform. So the first thing to do, of course, is to log in. And next, you want to create a new project. Well, we've already done that for you here for the sake of saving time in this webinar. So we're going to open this project up. The next thing to do, once this finishes loading, is to upload the images. So this can be done via this interface here. And again, we've already done this for you for the sake of the webinar. So let's get straight into the custom detector itself. So start here in the detector panel, as you can see on the left, and we will create a new custom detector. So we are given this image of trees, and the task for today will be to detect a specific type of tree. In particular, we're going to be looking for, if you can see this, these lighter green trees over here. And there are these darker green trees, which we do not want to detect, and also these more wild trees, which we also do not want to detect. So the first thing to do is to name your custom detector. I hope this is actually loading for you guys. It seems like the resolution is taking a bit of time, a bit of a lag in the webinar tool. But let's start it. There we go. And so now you should be able to see the types of trees that we are detecting. So let's just name this detector as my light green tree detector. Easy enough first step. The next thing to do is to create the training areas. So as we mentioned earlier, first of all, we want to find training areas over, make training areas over the objects of interest. And so it might look something like this. Maybe we will draw training area right over here. And note that you can rotate these training areas to suit your needs or scale them, etc. And now we also want one over background and also objects that we do not want to detect. So maybe here's okay. Now we have this sort of sandy background, this dirt background, some of these wild trees, and maybe some of these dark green trees over here. So that's a pretty good start. The next thing to do is to annotate these training areas. So the lower right-hand side one, we're going to do nothing, as we said before. And this upper one here, we are going to draw annotations. So now typically, if your objects have well-defined edges, it's better to outline more precisely the edges themselves. But of course, this is kind of difficult for certain applications like agriculture, where the foliage might be kind of fuzzy. So in practice, what we find is that you can actually just draw circles over the centers of these trees. Now, the key thing to note here is that the network is simply learning to output exactly what you give it as input. So if you input a bunch of trees with circles centered around the center of the trees, the network will learn to also output circles around the center of these trees. And just as in the case of the training areas, you can edit these shapes if you want to, and you can stamp them or delete them, etc. So after you have your set of training areas and your data, the next step is just as easy as clicking this one button here. And this leads you to a screen that looks something like this. So this whole training process takes 2 minutes. Remember that number, because oftentimes people will train neural networks, and sometimes it might take up to days to train, which is very infeasible for this whole iterative approach to improving your model. So these are the results, different set of training areas here, but still just two. So these are the results after one iteration. We're not going to wait for the training, obviously, since we only have half an hour here. As you can see, it does make a few mistakes. So it's missing a few of the trees over here on the left-hand side. It also seems to have some issue detecting these bushy green-like rows of plants over here, which we don't want. So what can we do? Well, we can draw, first of all, let's go and improve the detector. So all you have to do is click this improve button, which brings you back to the training area step. You can draw an empty training area over here for the stuff you don't want to detect. And since it seems to need some help here, maybe the trees look slightly different in this part of the image, then you can draw another one here and then annotate those trees. We're not going to do that. Just imagine that I did. And the results will look something like this. And so now you can see, at least in this area, it's doing a better job of not detecting these bushy areas. And also over here specifically, it's got all the trees in this area. The count is still not perfect. There are definitely way more trees detected in this particular example than there should be. And so if you keep on finding and iterating and training your AI baby a few more times, you'll eventually get results that look something like this, which is better. The count is lower than this, which is even better. So you really see that this iterative process is very, very important in training your AI model. And it's really you who has the expertise to determine what types of annotations to draw and what types of training areas to create as well. So once you train the detector, you can actually re-access it later by going back to the detectors tab here. And you can see that my light green tree detector is right here and ready to be used on any other similar imagery. Now let's look at a few different other use cases, just to show you that this generalizes beyond just this image. So now we have a more structured farm, maybe a more practical application. And here we're trying to detect the crops in the upper right, small crops as we call them. And so the results with each set of training areas look something like this. Again, there's a few mistakes, but they're easy to get rid of or to train away. Now over here, we have the same image, and now we're detecting citrus trees in the bottom left. So there they are, and the same thing. However, it's quite easy to train those away as before. In this example, we'll do something completely different. Now we will try to find construction areas where there are houses under construction. As you can see, there's a lot of annotations here, and we've only chosen a subset of them to be contained within our training areas just for demonstration purposes. But as you can see, with just these two training areas, we do a pretty good job at finding all the different construction zones. And I will let this load just for a quick second so you can see what the results look like. Okay, hopefully you saw that. So just for a preview of what our tool can do at scale, say you now want to export stats. So in order to do this, we have the stats panel, which is right here. So let's take a look at this final project right here, which is showing detections over this city area. So here we've decided to detect 7 different objects. This means I've trained 7 different custom detectors on each of this object, each of these objects. Basically, we tried to find everything we could count in this image. So we have roofs, trees, vehicles, road markings, swimming pools, solar panels, manholes. And once you have all this, let's say you want to export the stats. So click next. You can define a reporting area. And so this allows you to run stats over just a portion of the image that you've uploaded if you don't want to report over everything. But you can also just specify the whole raster just by drawing a large detection area, a reporting area just like this over the entire raster. So now here's our stats and report. It shows you the distribution of the counts and also square meter coverage of all the objects you've detected. After you do this, you can actually export your results into any of these formats: GeoJSON, CSV, KML, shapefile, and you can do whatever you want with them, maybe in another software such as QGIS or ArcGIS if you're familiar with those. So a key point to stress about this whole workflow is that it's not going to take months as it would with a consultant, for example. It takes maybe minutes, maybe at most an hour if you have a very complicated scene. And imagine if you were to say, take this original image we have here of the trees. Let's zoom out quickly and look at this gigantic area. There are these same trees all over this whole area. And if you were to try to, say, manually annotate them yourself, this could take months, if not more. With a custom detector, you can create a pretty high accuracy count over a matter of maybe half an hour or so. That's really the power of the custom detector. You are the one who is the expert of your detector. You create your AI baby, and you tell it what you want to detect. So that is the flow of the custom detector. And now I'll hand things back to Frank for some closing words.
Thank you, Roger. Thanks for this demonstration. I think it should be very valuable for the attendees to see how a custom detector is really trained and how you teach the model. I would like now to wrap up on the benefits specifically and give you some insights about our community and the future developments we are working on before handing over to Julien for the question and answer session. So, as you saw, the platform really acts as a single tool for you to handle the variety of applications you may have. It has this flexibility that allows you to build any detectors relevant for your needs. It really reduces the time spent analyzing your data. There's this hurdle of IT infrastructure that you don't need to have. You don't need to have an expertise in machine learning. You don't need to have annotators. So this removes a lot of labor. So you can really focus on becoming quickly an expert in the extraction of this geospatial information for your future analysis. Once the benefits are quantified, they are quite self-explanatory. So time-wise, we are moving from days and weeks to minutes and hours. So really have this huge factor of gain. In terms of cost saved, also there, you can remove all this infrastructure I was mentioning and the expertise. And you can focus in really bringing in the loop your expertise to really raise the accuracy of the machine learning models above the level you would have using regular annotators. We are trying to streamline your workflow, being compatible with the data coming out of the main photogrammetry softwares and allowing you to export into major GIS softwares too. The idea is really to keep it accessible, so without having a steep learning curve. And you can get your hands on it very quickly, as you saw from the demonstration. In as little as 10 minutes, you can already have a first detector. In terms of community, we are a growing community that started off last year in June 2018 with the public release. And then on, it has continuously grown. And we are today above 2,500 users over a wide range of geographies and very different type of use case and applications. We're constantly working on improving our service, and you will see further time gains, for instance, with batch uploads and a faster preprocessing of your image. The training of the model will also allow you to assess the accuracy without losing any additional time. The platform workspace also will evolve to be more intuitive and efficient when creating and applying your detectors. Finally, you will be able to further scale your operations with the ability to connect web mapping services streams and also detect over a set of areas of interest. We're also integrating into different softwares that you are mostly using, QGIS, ArcGIS, really to ease your entire analysis workflow. And so this gives you a little bit the way we are going forward in the near future. And I'm now heading over to Julien for the question and answer session.
Thank you, Frank. So thank you all for your questions in the chat. So we picked the 3 of them that we will answer now. So the first question that came a lot was what drones are compatible with Picterra? So this is a very good question, and the answer is that you can use any kind of drone to capture your image. So in that sense, we are hardware agnostic. And then we support orthophotos coming from all the major photogrammetry software like Pix4D, Drone Deploy, Agisoft Metashaped, Reality Capture, and others. So if you have a drone with which you can do TIFF orthophotos, we will support it. You can also work with single JPEG image, but they won't be properly geolocalized. We currently support RGB images, but you can do your own full color image and use them in Picterra, for example. The second question is, what's the minimum object size that your AI can detect? So to start, what matters is the object size in pixels, not the physical size of the object. We've had users who successfully used Picterra to identify objects that are as small as 5 by 5 pixels with a simple background. So this means that if the resolution of your image is about 1 centimeter, you can detect objects that are in a range of centimeters, basically. But of course, this depends on the type of objects and the type of background and the lighting condition and so on. The last question is around accuracy. So a question we get often is, what is the accuracy of the detections that I just did? And this is an important question, and we are working on this actively. We are actually currently beta testing a tool that will allow you to get accuracy scores for your detections. If you would like to participate in the beta test of this tool, you can send us a mail to support@picterra.ch. And you can also send us any other questions you would have later at that email address or in the chat. So thank you again for the questions, and we will follow up after the webinar with additional answers to some of the common questions that were asked and that I didn't have the time to answer right now. So I will now hand it over to Frank for the closing words of this webinar. Thanks, Julien. I think the questions were very relevant, and there was more, so there will be, as Julien said, an upcoming email where you will get answers to the questions, and also for the ones that couldn't follow all of the webinar or wants to replay it, there will be the link to be able to watch it again. So we really want to thank you again for having participated in this webinar. We hope it has been valuable for you, and we really invite you to try out the platform. The registration is free, so don't hesitate, really jump on it and have a start. We'll be happy to have any feedback on the webinar and the platform and your suggestions for any future webinar. So thank you all again, and see you soon. Bye-bye.